Welcome back to Geography Unpacked. So I thought let's pause geographical thought for a bit and let's move towards geomorphology. So the first topic of geomorphology which I am going to discuss with you all is the karst landscape. So karst landscape is a bit different from the other kind of landscapes which they find in the physical terrain of Earth, which is shaped basically mostly by the physical force of water, air or sea. But karst landscape is actually shaped by chemical reaction. So this entire topic of karst landscape I am going to cover in two parts. The first part which we are going to discuss today, I am going to talk about the process that is working behind the karst landscape and a few of the erosional feature, and in part 2 I am going to continue with the few erosional features which are left and the depositional feature. So to understand the erosional and the depositional features of the karst landscape, we first have to understand the process which is going behind the scene. So limestone rock, which is basically the constituent of the place where this karst landscape are found, is basically made up of calcium carbonate, which is CaCO3. So to understand this process, karst landscape formation, we have to travel back or recall our memory of our chemistry class. So CaCO3 or the limestone rock, which is made up of CaCO3, is basically a strong solid rock, but it has got one weakness: it reacts to acid. So when rainwater falls, it reaches the soil and it seeps to it and it reacts with the organic matter, picking up carbon dioxide or CO2 from it. So rainwater, which is H2O, and this carbon dioxide, which is CO2, together they form a weak form of carbonic acid, which is H2CO3. So when this carbonic acid mixed with rainwater reaches farther down to the limestone layer of the rock, the reaction starts to happen. So this carbonic acid reacts with the CaCO3 and form calcium bicarbonate. So the equation in this case goes as CaCO3 plus H2CO3, and the reaction creates CaHCO3 whole 2, which is the calcium bicarbonate. Calcium bicarbonate is actually soluble in water, so the water dissolves it and carries it along with it. So this way, slowly the entire solid form of landform is marked with holes and sinkholes, and it becomes a very irregular surface. Since we have understood the process and the chemical reaction which goes on behind the formation of the limestone surface, so we move into the erosional features. So the few erosional features which I'm going to discuss today, the first one is sinkhole. So sinkhole, when this carbonic acid reaches this limestone surface, it starts reacting and slowly a hole develop. So in this diagram you can see that these are funnel shaped depression are the sinkhole. This is where the water has found the joint and has entered and started the dissolution process, and this is actually a kind of primary drain to the landscape. So that was the sinkhole. Next come dolinas. So dolinas or the dolines are basically an aggregation of a few number of sinkhole. So in this diagram you can see it is a slightly bigger depression than the sinkhole. So as time passes, the individual sinkhole, they grow together, they grow wider and eventually collapses into one of this doline. So these features like sinkhole, dolines and eventually uvala and poljes, you can think it as the Russian dolls. Like we have one big doll and inside it we have another smaller doll, and inside it there is another smaller doll. So the smallest doll inside this Russian dolls is the sinkhole. So the one above, which is inside which it is put, is the doline, and then above that we have another bigger doll. It is the uvalas. So uvala is a collection of merged doline. It's an even larger depression. So in this diagram you can see that uvala is a slightly larger depression and it has an uneven bumpy floor, and it is a clear sign that multiple number of smaller dolines have converged to form the uvala. So next to uvala, that is the final bigger Russian doll, like the one which is there on the outside, is the Polje. So Polje is basically a huge depression which is formed by coalescence of a lot of uvalas together. So you can see this big huge depression in this diagram, and it's a massive flat bottom valley bounded by deep steep limestone cliff, the water flowing across Polje floor will eventually disappear into a pond. So we have covered sinkhole, which leads to Doline, which leads to Vala, and leads to Polje. So these are all together we can study. But there are certain other erosional features which are left. So in part 2, which is in the next video, we'll start with these erosional features like lapis and then natural bridges, and then we'll slowly move to the depositional features. That's when we'll learn what happened to the calcium bicarbonate, which was soluble and the water carried it away, and when it decided to come back in the solid forms and fall this magnificent pillars in form of stalactite, stalagmite, and the floor pillar and the caves forming the depositional features of limestone. So stay tuned, we are going to enter the caves in the next video. And if you have liked till what, please subscribe, and I'll see you in the next one.